Hello, here's a demo of using LabVIEW for some basic calculations and graphing. So the first thing is to start with some inputs on the front panel. This is where the user interface will be living versus over here the block diagram where we draw our program. So if I right click, I get the menus, and you can see here under numeric there are ones called controls versus indicators. So controls create data, things like knobs, send numbers out. Indicators display data, so meters, gauges. So these controls will have arrows going out on their blocks and indicators coming in. So I will put knob. You can see over here the arrow is coming out. I'll put a numeric control down. And then over on this side I'll display some things. So we use some indicators like a meter. Because the meter, if you send it a signal bigger than the maximum here, it just pegs the needle. I like to put an indicator underneath just to have both things to look at. So I've set up some inputs, set up some outputs. So this is controls, indicators, that's the lingo for LabVIEW. And over here in my block diagram, I can put some math. So there are two basic ways to do math with these kinds of variables, which are single scalar numbers. You can use just math blocks. So I've started in the Express menu, arithmetic, numeric, things like a multiply or addition block. There are other blocks here, things like the square, add one, subtract one. So I can do that. And then we wire them all together. So click over here, send it up there. These multiplied together, comes out, gets squared, and I can run it to the display. It's good to label everything so we see what's going on. So you can do it either here or over here. If you double click up there, we can call this input X, this input Y. This is X times Y squared. And that's the basics of math. There's another really common way to do math functions because this can get a little bit cumbersome. There's a formula block that hides all of the math. So again, over here, start on Express, arithmetic, and you'll find the formula block. The formula block, you have to configure the equation inside, and then it's just one block that does that equation. So you want to change the labels here. These are going to be the labels where you send the data in to have meaningful names. So I have X and Y. Not that meaningful, but usually you'd have quantities. So I'm going to do that. And then up here you can either type or you can use these buttons like a calculator to set the equation. So I want X times Y. If I want to square that, I can put in the parentheses by typing. You can see if there's a typo, this turns gray, and the typo's fixed, turns green. The one unusual thing is the power operator here instead of the, usually we're used to this thing like the caret. It's the double asterisk, so that's going to be squared. One mistake people do often is you put an equal sign in because you're used to Excel. This gives you the green light, but it will usually just give you zeros for the answer. So be very careful not to put an equal sign in your formula. So I've hit OK. You can see it gave me a place to type X, or wire up X and Y, so I can connect them up appropriately. I need something else to display, so we'll put another indicator down here. And then the result comes right out here. You can resize these and see things, and you can move the order around if you play around with it enough. Alright, so if I hit run, it will sample these two, do the math, and then update the displays. So if I move this up here, change that, hit run, you can see we get the same numbers whichever way we do the math. Sometimes we'd like it to run continuously, so we can use the run continuous button either here or here to do that. But there's a better way if you really want things to run over and over, and that's to use a while loop. So a while loop in programming keeps a certain block of code running until it's time to stop. And so we have that here too. And what we do is we find it on the tools. So under Express, this is execution control. Here's the while loop with a button. So if I click on that, it's a window. And so I drag it around everything. And then everything inside this window is going to keep running until I press either this stop button or the kill button up here. So the while loop is something we use all the time. So let me show you. So now I just click run once, and it's continuously running. And I can hit this stop button or this to stop it. Well, we're talking about the while loop. Remember, the while loop won't be on the front panel side, only on the block diagram side. And if you can't find something, you can always use this search, and you can type what you're searching for. So if you type while, it will show you while loop and while loop with button. And so if I double click on, I can just drag this out, or if I double click, it will show me where it is. But be aware that there's a confusing thing. This while loop doesn't have the stop button wired up. There's a stop signal that gets sent to actually stop the loop, and so you have to do that yourself if you use the regular while loop. You can right click and do create control, and it will fix it for you. Or you can just use the while loop with button that comes with it automatically. Alright, I'm going to delete that. And that's the basics of using these floating point numbers, math, and indicators. Alright, so I've got another VI started here just to show some of the waveform operations we can do. So I'm going to start over here on the block diagram, and I'm going to place a simulate signal. So from input, simulate signal block. I'll put this down here. And this is the one that simulates a function generator. So it's got frequency and amplitude. And I really want you to pay attention down here. This is a discrete system, so it has samples. So there are 1,000 samples per second here. So this is called the sample rate. There are 100 samples. You can uncheck this, and then you can change it to whatever you want. And it's showing us what we have over here. So if we had 3 samples, it would just be 3 there. 100. Harder to see, smoother. I always check simulate acquisition timing. That means it runs at the right amount of time. So these are the two numbers that we'll use often in sampling and data acquisition. We're going to get 100 samples at 100 samples per second. Sometimes we want to think about the spacing between these. If I go down to 10 samples, you can see the spacing between the dots. Sometimes that's an important thing. Sometimes how long we get data. Maybe we want a minute's worth of data. So those are some of the parameters. They're all set by these two numbers, sample rate and number of samples. And here is a little blurb of how they are. So these are so write this in your notebook. N is the number of samples. The units on this are just samples, but you can think of it as samples in the entire set, samples per set. Fs is the sample rate. It's a frequency, so F. And it's in samples per second, or hertz, which is frequency. Delta T is the time between samples, and so it's seconds per sample. And capital T we use as the sample period, which is the number of seconds in the data set. So over here we see a data set, and the sampling, the spacing between the points is our delta T, capital T, all those kinds of things. And there are some conversions that can be done here. Capital T is N times delta T, and delta T 1 over Fs. There are some weird things with this, whether you start with the sample at 0 or at the first sample. Usually we think of these kinds of things as being for periodic signals, so they start and repeat themselves, so we don't repeat the first point because it's the last point of the previous set. So sometimes there's an n-1 or n confusion, but these work. Usually rounding them off is just fine too. Alright, so the system here is fine. Over here I'm going to put something to graph it. I just want to show you that there are two kinds that we'll use commonly. So they're both under Express graphical indicators. There's a waveform chart and a waveform graph. So I'll put the waveform graph down, and then I will put the waveform chart down, and I'll wire this signal up to both of them, and then I'm going to place a while loop around everything. And now if I run this, you can see the difference between the graph and the chart. So the graph is slowly changing. The chart is growing over time. So what we have is the waveform graph gets the 100 points from the simulate signal. That's a set of data, and it just shows a single set. And then the while loop gets a new set and a new set, and because the frequency is 10.1 hertz, this slightly shifts every time. The waveform chart, on the other hand, gets the first set of data in the first time through the loop, and it gets the second set of data through the second time through the loop, and the third set from the third time through, and it just keeps them all. It shows the entire history. It actually, you can adjust this, but it ends up scrolling for 5 seconds, and you can change these usually just by clicking in there. If you wanted to start at 0, give you something like that. And now these are fixed, but you can see this is growing over time, where this is just showing the one waveform, the most recent set of data from there. So waveform charts we typically make really long so that they look better. And waveform graphs, especially if you're doing a single value, if you do a waveform graph, you'll just have a dot, or a waveform chart is the useful thing.